Okay, we're in section 16 of the notes. It's the review on the assignment on what's called the least common multiple, or LCM. So we developed a strategy for this, the algorithm for finding an LCM. The most important one is if you can do it by inspection, please do it by inspection. But we did talk about an algorithm for finding an LCM. All right, that depended on factoring. You'll see factoring is a common theme throughout the course. We use an LCM. We're going to see a lot of uses to LCMs, but right now we use the LCM to build fractions. Right? It's the opposite of reducing. We did addition and subtraction of fractions, which involves an LCM or LCD. We went through examples. Hopefully that's understood. Um, then certainly what I mean by this is we present information to you and we try to reinforce it by showing you examples. And so we went through all the examples. I'm hoping you paid attention. But for example, if you weren't paying attention, you can always go back over the notes and watch the embedded videos, or just watch the whole lecture again if you like at the end of the week. So here's the deal. We went through a bunch of examples. And again, the hope is that you've understood what was presented to you and you're starting to reinforce it. What's the best way to reinforce something? By doing homework independent. So I'm gonna switch to the whiteboard now. And we're gonna start doing the homework. Here's the hope though. You've studied and you've understood what was presented to you and you've done this on your own. And by doing it on your own, you're reinforcing what you're supposed to learn. All right, let's take a look. Get a nice clean whiteboard for you. And I'll write down what we're going to do. And what we're going to be doing is we're going to be doing, give me 1 second. We're going to be doing, first of all, we're in section 16 of the notes and we're doing the homework. And we'll start number 1. And number 1 says find the LCM. So they want the LCM between 6x squared y and 18xy squared. I gotta be honest with you. If you can look at this, know the LCM, just write it down. And it's kind of simple. But again, when I say it's simple if you see it. If you don't see it, it's not simple. So we go through the algorithm. The algorithm is to write down the completely factored form. 2 times 3 times x times y. Let's do 18 x y squared. What's that going to be? 2 times 3 times 3 times x times y times y. And the LCM is the algorithm we taught you in class. It's the factors that you see up here. What factors do I see? I see a 2. I see a 3. I see an x. And I see a y. And here comes the problem for a lot of students. It's the maximum number of times they occur in any one of those factorizations. So what's the maximum number of times the factor 2 occurs in any one of those factorizations once? What's the maximum number of times the factor 3 occurs in any one of those factorizations is twice. The maximum number of times the factor x occurs in any one of those factorizations twice. The maximum number of times the factor y occurs in any one of those factorizations twice. Do a little simplification. What do you get over there? 18 x squared y squared. We don't do much simplification on that. We're getting the same answer. Look at the k. What are you saying? You're seeing that answer. Let's go to number 2. Again, we're just reinforcing what you learned during lecture. Let's write this one down. Now there's 2 terms over here. The first term, 8x squared, which is partially factored, by the way, x minus 1 squared. The other term is 10x cubed, x minus 1. Now, you don't have to do this, but I want to point out this is 2 times 2 times 2 times x times x times x minus 1. I'm just explicitly stating every factor that's in the problem. This is 2 times 5, x times x minus 1. Now, again, what are we looking for? LCM, which is the least common multiple. Write the factors down. I see a factor of 2. I see a factor of 5. I see a factor of x. I see a factor of x minus 1. So I recognize those factors. Maximum number of times they occur in any one of those factorizations. Well, the 2 occurs 3 times, the 5 occurs once, the x occurs 3, and the x minus 1 occurs twice. A little bit of simplification. What do you get over here? 40 x cubed x minus 1 squared. Notice I say a little simplification. You're not to be multiplying this thing out completely. Just something simple. Let's look at the answer key. Again, if we're not staring at that, all I can say is I probably did something wrong. We want to try to correct those problems. So it's 40 x cubed x minus 1 squared. All right, let's go to number 3. Again, for this, if it's going too quickly for you, maybe you haven't studied, maybe done the homework yet, come back and watch this off schedule. All right, you can do that. Let's put number 3 down. And number 3, again, is there's 2 things here. They want the LCD, so the LCM between those. I know I have to factor this guy over here, so I'll put the factorizations down, x and x. If you're struggling with factoring, you need to go back to those sections on factoring. I'm going to say 6 and 4 minus 6 plus 4. Let's put the other guy down, which is x squared minus 36. That would be x plus 6, x minus 6. So again, a little more difficult, but I'm going to write LCM. That's least common multiple. What factors do I see? I see x plus 6. I see x plus 4. And I see x minus 6. The order doesn't matter, by the way. It's a multiplication problem. All right, here comes the tough part. What's the maximum number of times the factor x plus 6 occurs in any one of those factorizations once? What's the maximum number of times the factor x plus 4 occurs in any one of those factorizations once? All right, what's the maximum number of times the factor x minus 6 occurs in any one of those factorizations once? So I got it. X plus 6, x plus 4, x minus 6. All right. Now again, some people say I want to multiply it out. It doesn't pay to multiply it out. You could. It's not going to change it. Let's look at the key, though. And what's the key say? Let's look at it. And again, I want you to look at the key as well. I'm looking at the factors. I see x plus 4. I see x minus 6 and x plus 6. They're in a different order, but that's incidental, by the way. Let's put down number 4. And what's number 4? Again, it's another LCM problem. Let's write this down. X squared plus 3x minus 18. I'm going to factor it. The next guy is x minus 3. Yep, I'm going to factor it. And the last guy is x minus 2. Let's do one at a time. I'm factoring. I'm putting symbols on it, x and x. Let's see, 18, 6 and 3. Put it over here. Let's see if I can do that. Plus 6 minus 3. Looks good. So what I'm going to do, I'm going to write the LCM down. And what do I have to recognize? What I'm seeing. And I'm seeing a bunch of factors. I'm seeing x minus 2. I'm seeing x minus 3. And I'm seeing x plus 6. I actually see those factors. Again, going through it, what's the maximum number of times the factor x minus 2 occurs in any one of those factorizations is once. So I got it down once. How about the factor x minus 3 in any one of those factorizations? At most, I see it at once in any one. X plus 6, again, at most once. So this is the LCM. Again, I can't say it enough times to you. Please look at the answer key to make sure that you're looking at the same exact factors that we're saying it is. All right, let's go to number 5. Kind of jump and ship on this one over here. Now I'm starting to see things, and they're using something different. And they're using that LCD business over there. So write down number 5 for you. And what do you see? You see 4 over x, comma, 3 over x squared. And what they want is they want the LCD. So I'm going to write down the LCD is the LCM between x and x squared. Well, that's pretty simple. It's just x squared. All right, so I know what the LCD is. What they said rewrite the fractions so they both have the same denominator. So I'm going to claim over here 3 over x squared doesn't need to be rewritten, but 4 over x does. And what's the builder there? Well, what times x would give you x squared? X. Now remember this. If you multiply the bottom by x, you multiply the top by x. Let's write this over here. I'm going to put a box on it. What do you get? 4x over x squared, 3 over, whoops. Let me get my eraser. 3 over x squared. I did rewrite it, and they both had the same denominator, and that denominator is the LCD. Look at the key. Make sure you're staring at that. And if you're not, there's something wrong. Let's go to number 6. I know this is difficult. We're trying to encourage you to try. And if you are trying, you're not getting it, please come by during office hours, and we'll help you. This is 3. This is x minus 5, comma, and then what do you have there? 2, x minus 5 squared. Again, I got to get the LCD. You know what? I'm going to just move that 6 around a little bit. It's over here. Look like it's part of the problem. All right, I got to get the LCD. Well, I'm looking at it, and it's the LCM denominators. And what do I see? I see a factor of x, and I see a factor of x minus 5. Now, how many times do I see the factor x? Just once in any one of those factorizations. And I see the factor x minus 5 twice in one of those factorizations, right? So I got the LCD. Now here comes a problem. I got to put the builder in. All right, let's look at the first guy. I got the x minus 5. What am I missing? I have the x, but I'm missing a factor of x minus 5. So I need to write that down. Remember this. If you multiply the bottom by x minus 5, you multiply the top by x minus 5. Let's look at the next guy. Well, I have the factor x minus 5 squared, but what am I missing? A factor of x. So I need to write that down. All right, let's go through this. The denominator in both cases is now identical. What I'm left doing, though, is I'm left doing the numerator arithmetic. What does this give me? 2x. What does this give me? 3x minus 15. Put a box on it, and I'm going to look at the answer key. And what does the answer key say? 3x minus 15 over x minus 5 squared, 2x over x minus 5 squared. All right, let's go to number 7. Number 7, really relative to the same type of question. We're building on skills. And what do you see there? 7. I'm going to factor the denominator because I know it's important to get an LCD. And I'm going to factor the denominator here. You know what? Made a mistake. Let me just correct that. And again, I'm just looking at it. I think they're pretty good. So what I need to do is I really need to write the LCD down. And the LCD is the LCM between those denominators. Well, I see the factor x plus 2, and I see a factor x minus 1. That's the LCD. I got to build. And the first term doesn't need to be built. The second term does. What's the missing factor? X minus 1. Let's write it down. This is 7 over x plus 2, x minus 1, comma, well, it's still the same thing, x plus 2, x minus 1, same denominators. What do you get in the top, the numerator? You get x squared minus x. Put a box in this over here. And again, I'm going to get my little green pen out and see how I did. See if I did the right thing. I'm seeing this. And I'm seeing this. Good job. All right, let's go to number 8. A little different. All right. And we'll go through the steps. Right? The steps are important. You know the steps. 7 over 4y plus 11 over 6y minus 8 over 3y. Well, what they want me to do is simplify this. And the only way I could really do this is if I combine these 3 separate fractions together. But what I noticed, the denominators are the same. So my first goal is to get the LCD. I'm hoping this is not bad for you. Now looking at it, 4, 6, 3, I'm going to say the least common multiple there would be 12. And I certainly see why. Now what I got to put in is I got to put the builders in. This is where a lot of students struggle. Each one of these guys needs to be built. So let's do the first guy. And the question is this: what times 4y would give you 12y? Well, that would be 3. So it's 3 over 3. Let's go to the next guy. What times 6y would give you 12y? Well, that's 2. So it's 2 over 2. Let's go to the last guy, 3y. what times 3y give you 12y is 4. So it's 4 over 4. Let me go over here. What do I notice? Every single denominator is now 12y. Let's just do the numerator arithmetic. 21 plus, because 3 times 7 is 21, 22, because 2 times 11 is 22, minus, well, 8 times 4 is 32, right? Again, I got to keep doing arithmetic over here. And let me keep going. And you got 12y. What do you get on top? I guess you're 31, right? I'm sorry, not 31. You get 11. Let me just make sure. 22 minus 32 is minus 10. Yeah, put a box in this. All right. So yeah, equal. All right, let's see. Wow, I got that one right too. 11 over 12y. Let's go to number 9. Again, we're building on skill sets. I'm going to write down for you. What do you get? 2x plus 9 over 9x minus x minus 5 over 5x. Well, my first thing is the LCD. I'm looking at 9 and 5. I'm going to say a common multiple there would be 45. And of course, there's an x there. Let's put the builder in. And again, I want to emphasize what we're looking for. What times 9x would give you 45x? Well, that would be 5. So what's the builder going to be? 5 over 5. We'll do that later. All right, looking at the next guy. What times 5x would give you 45? Well, that would be 9. We'll put 9 over 9. All right, what do I know? I know this will be equal to something. The common denominator is 45x. I'm going to be doing these things separately, but a lot of students make a mistake here. I'll tell you why. The subtraction is what's killing them. Let's take a look at this. What's 5 times 2x? 10x. 5 times 9 is 45. All right, let's do the next thing, which might seem difficult to you. I want to point out what we're going to do over here. I'm actually going to say minus 9 times those two terms. What would that give you? Minus 9x plus 45. All right, let's see if we can do the numerator arithmetic. And what do you see? Well, 10x minus 9x is x, and 45 plus 45 is plus 90. Now, there's always a possibility a mistake has occurred. But before I say a mistake has occurred, I want to just see if I got the same answer that they have in the key. What did it say in the key? X plus 90 over 45x. Again, if you're struggling, all I can say is continue to struggle until you can master the material. And also seek out help if you do need help. Let's do number 10. And number 10 looks a little strange to me. It's 3 plus x minus 1 over x plus 1. Now, I think for a lot of students, the reason it looks strange is 3 is not a fraction, but I can write it as a fraction. I'm going to write the LCD down now. It's just simply x plus 1. Put the builder in. The second note isn't your builder. So what are you going to get over here? Pretty simple. You're going to get the same denominator, which is x plus 1. What do you get in the numerator? 3x plus 3 plus x minus 1. Keep going if you can. Push this up a little bit. Let's see, 3x and x is 4x. And 3 minus 1 is 2, right? This is a fine looking answer. If you want, you can factor the top because it is factorable. You get 2 times 2x plus 1 over x plus 1. It really doesn't help at all, but that's a fine answer too. Let's look at the key though. I want to point out looking at the key is important. Get 4x plus 2 over x plus 1. Worked out beautifully. Let's go to the next one, which can be number 11. Again, relatively simple questions if you've mastered the material. If you haven't mastered the material, nothing's going to be simple. Put 11 down for you. Now what's 11? It's 2 over x minus 3 plus 5 over x minus 4. Again, LCD. Factor the denominators. And what's going to be x minus 3, x minus 4. I'm going to build these guys now. What's missing from that second term is x minus 3. Remember, what you multiply the bottom by, you must multiply the top by. What's the missing factor of x minus 3 is x minus 4. Let's go through it. What's this going to be equal? Well, the denominators are identical. When the denominators are x minus 4, x minus 3. Let's do the numerator. 2x minus 8 plus, addition is generally much easier than subtraction, 5x minus 15. And keep going. X minus 4, x minus 3. Let's see, 2x and 5x is 7x. And let's see, minus 8 minus 15 is minus 23. Put a box in this. Yep, mistakes can happen. That's why we like to provide you with a key. And in the key, hopefully you're looking at these answers over here. What's the answer? 7x minus 23 over x minus 3, x minus 4. Let's keep going. We're going to go to number 12 now. And number 12 is, I'll write it down for you, 2x, x squared, minus x minus 6, minus 3 over x plus 2. Well, again, my first step is to factor the denominators because I need to get an LCD. Let's see, that's going to be plus 2 minus 3 minus, what do you get up here? 3x plus 2. Well, what's the LCD? I'll write it down for you. It's x plus 2 times x minus 3. I got to put a builder in, not in the first one, but the second one, which would be x minus 3. Remember, which multiply the bottom by, you must multiply the top by. Let's keep going through this. Same denominator, and the denominator is x plus 2, x minus 3. The numerator is 2x. Subtraction is more difficult, all right? So I want to point out what we're doing. We're doing minus 3 times those two terms. What does it give me? Minus 3x plus 9. Now let's keep going. And what do you get? Well, the bottom doesn't change. It's x plus 2, x minus 3. What do you get on top? 9 minus x. We'll put a box in that. Look at the answer key. And again, I want to make sure I'm looking at the same answer. I'm seeing 9 minus x on top, and I am seeing x plus 2, x minus 3 on bottom. Let's do number 13. And number 13 is the last question. All right. We're just reinforcing it, what you need to learn before you do the web assign. Let's put 13 down. And, oh, 13 looks bad, doesn't it? Let's write it down. As I do it, though, I'm going to just simply do it. And it's 6 minus 2x. On the bottom, I'm going to factor it. By the way, these problems are written to be relatively simple. What I mean by that, we're not trying to confuse you with a bunch of work, but we're trying to present procedure to you. Let's see if that works. You get 2x squared. That worked out beautifully. Then you get, let's see, minus 8 minus 7. That's minus 15. And you do get plus 28. So it worked out beautifully. Let's put the next guy down, which is going to be x minus 2 over x minus 4. All right, I'll factor that bottom. And last but not least is the last term, which is x plus 6 over 2x minus 7. Well, lo and behold, the LCD is really simple. It's 2x minus 7, x minus 4. The builders on the first guy, unnecessary, but in the second term, it's necessary. And what's that builder going to be? 2x minus 7, 2x minus 7. We'll do that later. What's the builder on the third term? X minus 4. All right, here comes the tough part. And for a lot of students, it seems to be too much work for them. But the bottom is 2x minus 7, x minus 4. I got to do the numerator now. What do you get? 6 minus 2x. We just did this. Now we're going to do this. And I'm getting better at multiplication. So, I get 2x squared. It's an addition problem. And then what do you get over there? Well, you get minus 7 minus 4, right? Minus 7 minus 4 is minus 11x. And then minus 2 times minus 7 is plus 14. Right? I'm going to do this, and I'm going to do it right above it. And what do you get? X squared. Let's see, minus 4 plus 6 is plus 2x minus 24. But I need to subtract that. So what do you get? Minus x squared minus 2x plus 24. All right, let's go through it. one step at a time. 2x minus 7, x minus 4. Let's do the top. I like to go in order. All right, so I look at one thing at a time. Look at this guy and this guy. They're x squared, right? How many do you have? 1. All right, I'm going to do the x's now. All right, so minus 2 minus 11. It's minus 13. Minus 2 is minus 15 x's. All right, let's do the constant now. 6, 14, and 24. Let's see, 20, 44, right? Now, someone says I make mistakes when I do arithmetic. Me too. I make mistakes all the time. So what I want to do is just look at the key, see if I got it, right? So I'm looking at the key, and what I noticed is they've got 2 answers listed. They do have this one listed, but then they got another one listed. I wonder how they got that. So let's take a look, see if we can do that. So it looks like they might have factored the top. Put that down for you. And that would be x and x. And 44, I'm saying like 4 and 11, right? And minus minus. Worked out beautifully. What happens here? Well, the x minus 4 cancels off. And that's how they got that final answer. I realize sometimes that's a really tricky question. But I'll be honest with you, I'd be happy to see this. I'd like to see that. But this is really our goal for you. Let's take a look, see if we got that. And that's what we got. Right, now a conditional true statement, but the bottom line is I wouldn't worry about the conditions at this point. I'm going to switch screens on you again. And again, I'm going to switch screens to the Sage stuff. Just give me a second to get you there. All right, so we finished the homework. And now I just want to carefully look, not carefully, but I want to look at the Sage stuff. Remember this stuff in the, that reddish color over there. If you click on it, it's going to open up a web browser for you. And it's going to bring you directly to the Sage Math website. Now that depends on your computer being properly configured. If it's not properly configured, it's probably not going to open the website. But anyway, you get to the website and you're going to go to this CoCalc. And it's like an online version of Sage, which is a Python programming language. All right. So what I want to do is just go through some code. Again, I'm hoping you see this code is related to what we've talked about in class. Again, we're going to go to CoCalc. I'm going to start a new project. It says it's stopped, but it will start it. What I want to do is create a new sheet like I've always done. Very consistent. I want a new piece of paper. You're going to title it. I don't care what the title is, though. I'm just playing around with Sage. I'm going to make a Sage worksheet. We've always done this before. And I'm going to start typing things in. So what are you going to type in? Well, their code. Reset. I'm trying to learn. Remember, shift return. I'm going to say X is a variable. We've done this many, many times before. And I'm hoping you're catching on. All right. And then LCM. LCM stands for least common multiple. It's a function call. 50-50. Right? Put this over here. Well, that makes sense. Let me try another one. LCM. Let me try, I don't know, 60 and 45. I think you can do it. It says 180. All right, let me try something I don't think you can do, though. Wow, they did it. Someone says, how could you check that? That would be a really tough one to check, by the way. But I'm not interested in that. What I'm interested in is this code over here. And I'm getting tired. I'm going to copy paste. By the way, I typed in this code already. This is something I've done prior. So what does it want? The LCM between those two polynomials. This seems weird to me, though, because what they say is they want to put it in factored form at the end of it. So there's two functions being called over here. The LCM between those two polynomials, and then also the factored form of the answer. Again, shift return. Again, these are problems that we've done before. And they say stuff, can I do that? Of course you can. All right, of course you can. Now, certainly there's other code down over here. You want to take a look at it. For example, let me look at this one over here. Something we've done before. It might look strange to you. And that's the problem with code. Code does look strange. All right, what do they want me to do there? I guess they want me to simplify that guy over there. And what do I get over there? It might be hard to read, but it's actually 11 over 12x. All right, that's it. Hopefully this has been helpful. Please consider getting help if you need help.